Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to wrap up our discussion on the ways that we generalize by talking about the last three methods, specifically exaggeration, enhancement, and displacement. This has a little bit more room here, right? Specifically exaggeration, enhancement, and displacement. Now, what makes these three things unique is that we are similar to merge. We're altering the underlying geometry to enhance the visual identification of a particular feature, right? So this would happen when the thing being represented and understanding what that is more important than the actual real life geometry and location of the underlying spatial data. And that'll make more sense when we look at some examples, right? So what exaggeration does is exaggeration, right, changes the geometry to make a feature more distinctive and obvious. Right, it changes the geometry of the feature to make it more distinctive and obvious, right? So the example that they give in the book, and I think this is a pretty good one, right, is the idea that, say we have a shoreline, right, and our shoreline, right, does something like this. But we want to make abundantly clear, right, that this here is a bay. Right, our mapping purpose specifies, right, that this bay and this inlet is critical. So what we would do is we would alter the geometry slightly. I don't know what that was. Right, that we would alter the geometry slightly. Right, we would exaggerate, right, the bay. So this bay is now exaggerated, even though there's no change in scale, right? I want to be clear here, right? No in scale, right? So unlike the last times, actually, let me do that in red. That's not to say there can't be, but in this particular case, right, we haven't changed the scale at all. We simply moved vertices, right? We simply moved vertices, right, to exaggerate the fact that this bay is here and that this inlet is here. Right, that's what I mean when I say exaggeration, right? We've exaggerated, right? We've exaggerated this feature here, right? This bay has been exaggerated. Because for the map that we're making, knowing that this bay exists and that you can get through this inlet was more important to the map purpose than actually matching perfectly with the reality of what the shoreline looks like. Okay, so that's exaggeration. Enhancement is very similar, but slightly different. In that enhancement, the idea is that you use symbology, right, to emphasize the relationship between features, right? So with exaggeration, we were actually changing underlying geometry. With enhancement, right, we're changing symbolization, right, to highlight relationships, right, between features. And the symbolization versus geometry is very important. So let's, for example, imagine we have, right, two roads in the road data set that go like this, right? Now, we don't want to exaggerate, right? So they cross, right? They have a cross here. So exaggeration would mean changing the geometry. We don't want to change the geometry, but we do want to highlight the fact, right, that the blue line goes over the red line, right? The blue line is a bridge. Right, so we're not going to change the geometry here, right? And again, no change in scale. Right, but we want to make sure that it's clearly identified that this blue line is on top of the red line in the sense that it's a bridge, right? And so what we might do in symbolically, right, is we might do something that looks like this. Right, we might take our red pen here and we might do something that looks like this, right? Symbolically, right, we might make something that looks like that. And then the blue line would be drawn like that, right? So now it's clear symbology wise, right, that the blue line goes on top of the red line. So we haven't changed geometry. We've just used symbology or symbolization, right, to highlight this particular interaction here. Okay, so the last thing we can do is what's called displacement. Right, and displacement really deals with that idea of coalescence or conflict, right? And let's say, for example, right, in our original data set, we had, right, a road. And then next to that road, we had, right, a train track. And when we go from large scale, right, to small scale, right, just like we talked about in our example when we had this the fictitious example of coalescence, right, we now end up with these two things on top of each other, right? They're on top of each other. So visually, we wouldn't be able to tell them apart because at the scale that we're at and the way that we symbolize lines, these are indistinguishable. What displacement would do right, is displacement would artificially adjust the geometry to offset them so that they're visible again, right? It might, right, it would do something like that. So this gap now, this is artificial. Right, this gap, this is an artificial gap. Right? Right, we've recreated this gap so that we could clearly see the road and the railway, even though in reality, at the scale that we're working at, they would be on top of each other. Right, so displacement, right, artificially changes, or not artificially changes, right, changes geometry. Right, it physically moves an object of a feature to reduce coalescence. Right, so with exaggeration, we were changing geometry to make a feature more distinctive or obvious. With displacement, we're changing the geometry because if we don't, then two objects would be on top of each other, and we don't want to just get rid of one. So we artificially move one so that it's clear in the map that they're both there rather than being on top of each other. So hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.